Hi, this is ChendiXue. Today I want to present Boosting LLM Data Preparation with Spark as a demo video for Data AI Summit. Firstly, data is essential to enterprise large language models for many reasons. Privacy challenge prevents enterprise to use LLM models with unclear ethnical AI liabilities. Converting enterprise data to be utilized by LLM fine-tuning or RAG process needs a lot of work and will be slow at large. Data preparation should be customized to different companies due to legal consideration, standard consideration, and the privacy consideration. Meanwhile, I also want to share with you of our investigation to conclusion journey for why we want to adopt Spark as the underlying data platform for large language model data preparation. From previous investigation, we found that Facebook CCNet reports 8.5 hours on 5,000 cores to process 1.5 billion common core data. Google C4 reports about 335 CPU days to process a 10 terabytes common core data. And with Spark, lazy execution and its native distributed mechanism, we are able to complete the data creation for foundation model from common core just in a couple days. For deduplication technology, which is widely used in a lot of fine-tuning dataset preparation, especially for alpaca dataset preparation, they will use an algorithm called Rouge-L comparison, which needs a Cartesian production comparison to all samples. So it will be very slow when dataset is large. But with Spark, it will be more feasible to process with its optimized aggregation and join support. Also, we found that Spark built-in mechanism for document loading, partitioning, and shuffling technology also accelerate the process of RAG loading and indexing. And in this session, I want to share with you of our 4 low-code LLM data process pipeline. All these 4 use cases will be leverage Spark dataframe-based API, and the detailed implementation will also be shared during this session. And for these 4 use cases, which will include the foundation model data preparation, data pipeline for fine-tuning data with prompt formatting and quality control, data pipeline for retrieval augmented generation for multiple enterprise data sources like images, PDFs, video, and URL crawler, and also a data pipeline for LLM data quality evaluation. Okay, for the first page, which is data preparation for foundation model, we want to show you how easily it is to convert a paper method into a Spark pipeline with our wrapped APIs, like something shared on the right. For the data preparation for fine-tuning data, this is a diagram of using the method to formatting and to improve the quality of the data for fine-tuning. And which is shown on the left, we can see how big the improvement it is to improve pre-processed data to a post-processed data. And in the example for retrieval augmented generation, we want to show you as all the supported data type on the left and how to loading data from a document folder to have everything imported into the pipeline and convert into a lot of samples and then indexing into the document store like Elasticsearch, FastStore, or Chroma. For the quality control pipeline, we want to show you how to use the Raptor tool to do all the data quality analysis, including quality score, which is using a GPT-3 model to do that, um, a toxicity analyzation, which is using a BERT model or a perspective API to do the evaluation, and the perplexity score for dataset to understand what is the PPL number of the dataset, and also the diversity analysis to understand how diverse this dataset still containing. After short brief introduction of all 4 use cases, we also want to share with you how to use Spark to implement this. The first example is to show you how to Spark do document loading and indexing. Because we have built-in document loading technologies from Spark, and also we can using some tools like LangChain to do that. We simply using Spark as a distributed platform to get all the data loaded into a shuffling data frame, and then we can use that to indexing into the document store as the code shared on the right. And for the global aggregation, which is used by RougeL diversity indication and LSH deduplication. This is code for using Spark to do that. The idea is like we will have a n sample and we need to have a Cartesian production for this n sample. Then we will have a n multiply n matrix for that. But with Spark, we can using the product join with a built-in algorithm, aggregate and join algorithm, and then convert it into a graph. It will be way easier to do that than just using a Python code. For the implementation for map and filtering, it is very simple and direct by using the built-in user-defined function from Spark to do that, and we will also share here. So this is a completed list of all the functions we have implemented at this moment. The takeaway of this session is to provide a way for audience to easily convert an edge paper method into a Spark-based parallelism implementation. At this moment, we may only have implemented 30 plus algorithms into Spark codes, which are based on the conference papers. We want to bring more methods in the future for better supporting to enterprise data embedding into the LLM process with no pain. Thank you.